All right, today we're going to talk about lesson 6.2, which is solving systems of equations by the substitution method. Okay, so our goals for this lesson, the now is to solve systems of equations by using substitution. And our second goal for the lesson is to solve real-world problems involving systems of equations using substitution. And for this lesson, we have one vocabulary word. The definition is going to be one method of finding an exact solution of a system of equations, and that is going to be the substitution method. So our key concept for today is solving by substitution. So step one, when necessary, we want to solve at least one equation for one of the variables. In some of the examples that you see today, one of the equations might already be solved for you, so you won't have to do step one all the time. However, if both equations are in standard form, you will want to solve one of them for either x or y. It just depends on the problem. Step two, we're going to substitute the resulting expression from step one, so whatever one we solve for, into the other equation by replacing the variable. And then we want to solve the equation for the other variable. Finally, in step three, we want to substitute the value from step two into either equation. Okay, and it doesn't have to be the original equation. You could substitute it back into the equation that you solve for one of the variables. So once we solve for the other variable, we're going to write our solution as an ordered pair. Remember, that is an x, comma, y value. So taking a look at example number one, here it says to use substitution to solve the system of equations. So if I look back at step one, we want to solve at least one of the equations for one of the variables. Our first equation, y equals negative 4x plus 12, is already solved for y. So I really don't need to do step one here because y is already by itself. So going off of step two, says substitute the resulting expression from step one into the other equation to replace the variable. So I'm going to take what y is equal to in the first equation, which is negative 4x plus 12, and I'm going to put it in place of that y. So I have 2x plus y, but instead of writing y, I'm going to put parentheses in its place, and that's all going to be equal to 2. So I am taking y out, and I am putting negative 4x plus 12 into its place. Notice I've got one equation with one unknown, so my unknown here is x. Once I find the value of x, I'm going to take that and substitute it back into one of the two original equations to find the value of y. So simplifying here, I have 2x plus negative 4x. That's going to give me negative 2x. I still have this plus 12, and it is all equal to 2. In order to get x by itself, I first want to get rid of this plus 12 by subtracting it to both sides. When I do that, I am left with negative 2x is equal to negative 2 minus 12 is negative 10. And now I want to divide both sides by the coefficient in front of x. So if I divide by negative 2, divide by negative 2, a negative divided by a negative is a positive. 2 goes into 10, a total of 5 times. So part of my answer for this problem is going to be 5, comma, some number. And that number comes from taking this 5 and substituting it back into either equation. Now, since the top equation is already solved for y, I'm going to substitute it into the first equation for x. So y equals -4 times x plus 12. But instead of putting in x, I'm going to take what we found x to be, which is 5. And now I'm going to simplify. So -4 times 5 is equal to -20. So y is equal to -20 plus 12. And then simplifying that, -20 plus 12 gets me -8. So y is equal to -8. So my final answer written as an ordered pair is 5, -8. For the check your progress, okay, you are going to do this example on your own. So go ahead and pause the video. When you have a solution, unpause your video and check with my answer. Alright, so in the check your progress, if you did this problem correctly, you should have gotten 1, 2 for your solution. So take what y is equal to, substitute it into the second equation. So you get 3x plus 4 times the quantity 2x is equal to 11. 4 times 2x becomes 8x. 3x and 8x is a total of 11x. So 11x equals 11. Divide both sides by 11 and you get x is equal to 1. From here, take and substitute it back into one of the two original equations. So 2 times 1 is 2. So this is where you get x is 1, y is 2. And then checking your solutions. 2 times 1, which was x, gives you 2, so that checks out. And then 3 times 1 is 3, plus 4 times 2 is 8. Remember, x was 1, y was 2. This does indeed equal 11, so 1, 2 is your final answer. In example number 2, here it says that we want to solve and then substitute. So we are going to use substitution to solve the system of equations. Over here in bold, remember to follow the steps in the key concept. So our first one is to solve at least one of the equations for one of the variables. Here both equations are written in standard form. So I can solve for x or solve for y. I'll tell you which one to do, just make it whatever one looks easier to you. So in this example, since 1 is the coefficient for x, I'm going to solve for x because I don't feel like dividing everything by -2 if I were to solve for y. So in order to get x by itself, I'm going to take x minus 2y equals -3. And so I want to add 2y to both sides in order to isolate x. So I get x is equal to 2y minus 3. So I'm going to substitute in 2y minus 3 for x in the second equation. Okay, so when I do that, I have 3 times x plus 5y equals 24. But in place of x, I am putting this 2y minus 3. So now I have one equation with one unknown. That unknown is y. So when I solve here for y, I'm going to get the answer and substitute it back into one of the two original equations and find the value of x. So simplifying, do not forget to distribute. So 3 times 2y is 6y. 3 times -3 is -9. And then I have still this plus 5y, all equal to 24. And now I want to combine like terms. So my like terms in this case would be 6y and positive 5y. 6 plus 5y is 11y. I still have this minus 9 that I didn't use, and it is all equal to 24. So from here, in order to get y by itself, I'm going to add 9 to both sides, trying to isolate y. So 11y is equal to 33. And then divide everything by 11, and we get y is equal to 3. From here, what you want to do is you want to take y, which is 3, and substitute it back into one of the two original equations. Now, you can go ahead and substitute in 3 to the first one and then solve for x. However, you already did the work here to isolate x. So instead of substituting it into one of the equivalent equation or one of the original equations, I'm going to substitute it into the equivalent equation, which is still from the original. So x equals 2 times y minus 3, and we found y to be equal to 3, so I'm going to substitute that in. And now simplify. 2 times 3 is 6. And I still have this minus 3, and that is going to give me the value of x. 6 minus 3 is positive 3. Now my answer has to be written as an ordered pair. So if I'm going to write it as an ordered pair, remember x comes before y. So positive 3, comma, positive 3. This is your x value and your y value. Okay, go ahead and pause the video. Do the check your progress problem A. When you have a solution, unpause your video and check with my answer. Alright, if you did this problem correctly, you should have gotten negative 2, 6 for your answer. Okay, I solved this first equation for y, so the first thing I had to do was subtract 3x from both sides. After I did that, I got negative y equals negative 3x minus 12. To get rid of the negative, I divided everything by negative 1. So that changed the signs on both of these. So y equals 3x plus 12. Since y is by itself, I substituted in 3x plus 12 into the second equation for y. So negative 4x plus 2 times y, which we said was 3x plus 12, is all equal to 20. First thing I did here is distributed. 2 times 3x is 6x. 2 times 12 is positive 24. I brought negative 4x down, and that is all equal to 20. From here, combine like terms, so negative 4x plus 6x is 2x. Didn't use the plus 24 or the equals 20. In order to get x by itself, I subtracted 24 from both sides, so 2x equals negative 4. 20 minus 24 gives you negative 4. Now divide everything by 2, and you get x is equal to negative 2. I took this negative 2, substituted in for x into the equivalent equation from the first one. So 3 times negative 2 gave me negative 6 plus 12. Negative 6 plus 12 is equal to positive 6. So negative 2, 6 is your final solution. In example number 3, it is possible that when we solve these systems of equations that we get no solutions. If you remember from graphing, no solution would be where the two lines are parallel. So you'll have the same slope, different y-intercept. Or if you have infinitely many solutions, you have the same exact line. So you'll have the same slope and the same exact y-intercept. So in order to do this, again, we follow our steps. So step 1, we're going to solve at least one of the equations for one of the variables. If you want to, you can solve this top equation for x or y, but you are going to divide by 2 in both cases. I could solve this bottom equation for x or y, and since both coefficients are 1, it's entirely up to me which one I want to solve. Since I'm most comfortable with solving for y, I'm just going to go ahead and solve that. So I'm going to subtract x from both sides. So I get y equals negative x minus 2. And now I'm going to take and I'm going to substitute in negative x minus 2 in for y into that top equation. So I have 2x plus 2 times y, but instead of putting in y, we're going to put in this negative x minus 2, and that is all equal to positive 8. So the first thing I want to do here is distribute. When I distribute, 2 times negative x is negative 2x. 2 times negative 2 is negative 4. I'm going to bring down 2x. I'm going to bring down equals 8. From here, I want to combine like terms. So 2x minus 2x. Those actually eliminate because they make 0. And I'm left with negative 4 equals 8. Now at this point, when the variables have been eliminated, and this is the only case where the variables have been eliminated, in our previous example, if I go back up, notice there is an x left in the problem, so this has a solution. There is a y left in the problem, so it has a solution. In example 3, there is no x. Okay, so you have to ask yourself, is this a true statement? If it is true, your answer is going to be infinitely many solutions. If your answer is not true, aka false, your answer is going to be no solution. And since negative 4 is not equal to 8, our answer here is no solution. So what does that tell us? It tells us, if it's no solution, that these two lines have to be parallel, meaning they have the same slope but different y-intercepts. So these two lines will never ever intersect if we went to graph them. What I would like you to do is I would like you to try the check your progress. Once you come up with a solution, go ahead and hit the pause button again, or the play button, and check your answer with mine. Alright, if you did this problem correctly, you should have gotten infinitely many solutions. We'll go ahead and walk you through that process. I decided to solve the top equation for y because that's the most comfortable that I'm used to. I could have solved the bottom equation for x or y. I chose the top one because it had smaller values in every case. Our x values were smaller, y values smaller, and then our constant at the end was smaller. So I subtracted 3x from both sides to get y by itself. That eliminated, so I resulted with negative 2y equals negative 3x plus 3. From here I divided everything by negative 2. So I got y equals 3/2 x minus 3/2. So at first appearance, this turns out to be a not so nice number with a not so nice y-intercept. However, when we substitute it into the bottom equation for y, we get negative 6x plus 4 times a quantity. This is our y, so 3/2 x minus 3/2. 3/2 x minus 3/2, all equal to negative 6. When we distribute, 4 times 3 is 12. 12 divided by 2 is positive 6x. 4 times negative 3 is negative 12. Negative 12 divided by 2 is negative 6. Didn't use negative 6x, so I brought that down. And I didn't use equals negative 6, and I brought that down. When I go to combine like terms, negative 6x plus 6x cancels out because it makes 0. So I'm left with negative 6 equals negative 6. This is a true statement. So my answer is infinitely many solutions. So now we are left with our real world example. So this is a word problem and how we can relate it to systems of equations. So it says a nature center charges $35.25 for a yearly membership and $6.25 for a single admission. Last week it sold a combined total of 50 yearly memberships and single admissions. So 50 total, it doesn't tell us how many of each. That's for us to figure out. When they sold these 50 memberships and single admissions, it was a total of $660.50. So our question is, how many memberships and how many single memberships were sold? So I am going to let M represent our yearly membership. I'm going to let A then represent our single admission. Okay? So I know that between the two, there was a total of 50 of these sold. So I know that A plus M has to be equal to a total of 50. Now, each single admission cost $6.25. So $6.25 per single admission, plus our yearly membership is $35.25, so that's $35.25 per yearly admission. And that's going to be equal to the total cost, which was $660.50. So when we go to set up this system of equations, we're going to have one that talks about our total amount sold, and then we're always going to have one that involves a cost equation, or in this case, a cost equation. Okay. So now, since we are going to use substitution in order to solve, we can choose to solve the bottom equation and deal with decimal answers, or we can solve the top equation for A or for M and then substitute it into the second equation. So I'm going to go ahead and solve that top equation for A. So this A plus M is equal to 50. I'm going to subtract M to both sides. So A equals negative M plus 50. And now I'm going to take this negative M plus 50 and substitute it into the bottom equation for A. So I have $6.25 times A, which we now said is negative M plus 50, plus $35.25 for a yearly membership, and that is equal to $660.50. Okay. So now I have one equation with one unknown, that is M. So the first thing that I want to do here is distribute. So when I distribute, I get negative 6.25 M plus 625 times 50 is going to give us 312.50. I did not use this plus 35.25 M, and that is all equal to $660.50. So combine like terms, I have negative 6.25 M plus 35.25 M. That is going to give me a total of 29 M plus 312.50, all equal to 660.50. And now I want to solve for m, so I'm going to subtract 312.50 from both sides. So I'm left with 29m is equal to, when you subtract this, you get 348. So now in order to get m by itself, we're going to divide both sides by 29. When we divide by 29, we get m is equal to 12. So that means that the number of yearly memberships that this nature center sold was equal to 12. Okay, so I know that between the yearly membership and the single admission, there had to be a total of 50. So now I'm going to take 12 and substitute that in for m. So a plus m equals 50. I'm going to take out m and put in 12 in its place. And now I want to solve for a. So I'm going to subtract 12 from both sides. And I get that a is equal to 38. So that means that there were 38 single admissions sold. This one, you don't have to write your answer as an ordered pair. You can keep it as this. So 12 yearly memberships and 38 single admissions.